Now, let's go back to the session that we have today. And today we had a very interesting session, network services orchestration, service as a code, so you can imagine what you can expect. And the session will be presented by my colleague, Maciej. So everybody welcome Maciej.
Good morning, everyone. Can you all hear me well? Okay, brilliant. My name is Maciej Małysz. I'm software architect within a customer experience organization, and I would like to talk to you today about NSO Service as a code. It's a concept that looks into the infrastructure as a code, looks into the GitHubs, looks into interacting between developers and operations. What I'm presenting here today, you can find following the QR code, there is a GitLab repository that I've used to present a concept that I'm going to talk about today. It all starts with an intention. And from one side, we can look into more technical aspects of the solution. From the other side, we can look into a more human-related or relationship between the operations, developers, between different teams that are engaged into the whole overall concept. As you can see, I'm just here putting a picture of my badge. Unfortunately, a special character, which is L, a Polish letter, hasn't been supported. And that's how usually the things go wrong when we look into the intention that is coming from the operations, now when we want to implement it. It's all about the intention and about planning. How do you make sure that you get the intention from the very beginning till the end? What we did see in practice is that when there is a need to develop something, to come up with a solution, developers quickly jump into typing the code, getting the code ready, getting the code deployed into production. And then it figures out that, well, it doesn't do the work, right? I was trying to find a quote that could help to identify it. I found a quote that it seems to be by Abraham Lincoln. I'm not sure if it is by Abraham Lincoln because that's just what Google told me that that's the origin of it, but whether it's true or no, I don't know. But the quote is like nice. I mean, give me 6 hours to chop down a tree and I will spend the first 4 sharpening the axe, right? Let's focus on planning. Let's focus on making sure that we get through to know what we want to achieve before we start doing the work. I would like to focus and explain a couple of things. To start with the operations experience, then to look into infrastructure as a code from the perspective of NSO, and then show you the setup that we're building, the setup to use NSO to build, based on the NSO service intention, the deployment into an environment. What kind of environment it's going to be? Well, it's going to be depend, right? Because do you want a repository to be source code, to be single source of truth of your network? I think that the opinions are definitely shared, right? Some people say it might be a nice idea. Some people say no way, network is always source of the truth, right? And I think that if you look into, deploying the Kubernetes clusters, where it went hand in hand, the whole DevOps world together with the advance of the technology, and it was much easier to define that the repository is going to be single source of truth. If you look at the network, there is a lot of disconnect between what is in the network and what we believe that is in the intention. So if you don't want to define the intention and push it down to the network, and you don't have ways to validate it, that the actual operations and the services are running fine, then you might end up with dramatical outages because there was some configuration in the network that nobody knew what it is doing because that guy that configured it left the company a very long time ago, but we don't really know how to replicate it and how to discover it. So I'm not saying that this is the way to go ahead with all the different implementations. It will depend on the organization. It will depend on multiple aspects. The key message in here is your mileage might vary, and you need to find the most appropriate solution for your organization. There were 2 sessions that were yesterday, unfortunately at the same time, so you couldn't attend both. one from Alfonso, another one from Lionel. They were touching the NSO within the DevOps land. They were touching the infrastructure as a code for a data center. I'll definitely recommend you looking into those if you'd be interested more. And I actually took opportunity to borrow one of the slides from Alfonso, because I think it really perfectly describes like how the operations are getting involved, right? So the operations, they say, okay, I've got an idea. I want to implement a specific solution, right? Please do implement it. And the developers start doing the work. And the whole story goes, and the story can fail, because what is happening, operations do define the requirements, but then they don't have time to get involved with the developers. So developers work, they deliver the solution is demoed to the customer, the demo is accepted, so we want to go into production. Then operations, they say, oh, but we didn't validate the solution. Say, well, how did you validate the solution? We did the ATP sessions. Oh, but the ATP sessions was done with a different department that is actually paying you, but we're paying them. And actually, we don't know how to validate it properly, right? So, and that's quite a common challenge that we are facing in a number of engagements with the customers, right? It's not necessarily a technical problem. It's much more mindset, relationship, business, sometimes political. So what I'm trying to show in here is how do we find a way to get operations involved into the whole process of delivering solution, delivering NSO services as quickly as possible. And here, the infrastructure as a code with NSO is a concept that might be applicable. It not necessarily might be applicable to go to the production, but it might be applicable just to jump and to start doing it in your lab, staging environment, pre-production. So infrastructure as a code, for those that haven't been familiar with this topic, it's a concept where we're defining our intention within the source code repository. Now, this intention is done in a hidden and both machine readable form, so it's easy for a human to define it, so that it can be later on pushed down through an automation, through a CI/CD pipeline, through software automation tools like Git, and there are a number of tools out there that can help with. You find a way to deploy it, to push it down to the network, into the physical infrastructure, into virtual infrastructure, deploy the virtual infrastructure into network elements finally, routers, firewalls, virtual devices. Now, what are the huge benefits of infrastructure as a code? First of all, you can deploy it with the speed of the light. You go, you deploy it quickly, it goes down into the network. You want to build it, you want to destroy it, it's actually at the speed of the light. Well, maybe not at the speed of light, but pretty quick, right? Now, you can deploy multiple similar environments, testing environment, production environment, pre-production, staging. There are different conventions, like you start with P-5 down to P0, which is your actual production network. Now, the concept about how do you structure your environments to make sure that you go through from the unit testing to the actual production deployment, it's a different story, right? But regardless of how you structure it, you're going to be able to deploy it into various environments. Now, you can execute it through CI/CD pipeline, and you can execute it using a number of declarative tools, and those tools are out there. And you did see stories like, for example, if we're looking to data center, ACI as a code, which is maintained within the repo. Cisco helps to deploy data centers automation through ACI as a code, where we're using Terraform. And we do have Terraform providers that help to deploy the configuration down to the data centers. But there are different tools that are out in there, right? One important aspect is when something fails, you can easily roll back, and that's as well fully automated. Now, NSO is yet another tool that perfectly actually fits into this ecosystem, right? There are and there have been a number of different sessions and presentations. How do you compare functionality of Ansible, of Terraform, of NSO, where one complements another, what are the strengths and the weaknesses of one, what kind of ecosystems it's much more applicable, right? If you talk about deploying infrastructure, if you talk about configuring it, if you talk about configuring network elements, it all depends which one you want to choose. And there are pros and cons of one versus another. if you look at NSO, right, NSO comes with a huge number of unique capabilities. You've got fast map that helps that you just define, create. You don't need to take care about anything else. You've got a very nicely defined data model that helps to validate your solution, reach APIs. So is that the GitHubs? Is that something that we can look into it from the perspective of actually storing and saving our infrastructure intention or service intention within the repository? So let me explain you how I would like how did I set up this this demo, this concept. The concept is pretty simple, and it's shared on the GitHub so that you can actually take an example of it and try to use it, give it a go, right? So we are started with the fact that we're defining our infrastructure, our service intention within the service YAML file. This service YAML file basically has a very similar structure to our final service, right? The principle is to make sure that it's easy to understand, that it has a direct mapping into the service. Once that one is being defined, we do have, and then this, this infrastructure as a code for NSO service is kind of implemented in a nutshell in a provisioning Python script where we're just translating it, is pushing it through the REST conf into NSO, and then NSO is deploying it down to the network elements. And NSO basically gives the proper transaction, pushes the transaction down to the network, takes care about the integrity, and it is the way where we can engage our operations, right? Because I'm showing you right now the flow, how it goes step by step. Now, this flow could be for developers, but could be as well for operations. The concept is based on the fact that each developer is going to have in his local environment a set of two different containers. One container which is the GitLab runner, another container which is the NSO with the service. So a developer develops the service, builds the package locally, it creates the NSO container with that package that can be used later on for testing. So developer, and there is the NetSim test environment that is built into that one. Obviously, that doesn't have to be NetSim environment. It could be the CMS lab that I think some of the people were explaining earlier, where you can actually look into having a virtual instances of the devices, because NetSim, it only allows you to simulate the device based on its data model, right? Obviously, you can play with it to define some shell scripts that are going to behave like a proper device would be, but it's just mocking the system, right? Okay. Developer or a user or an operator pushes the service's YAML file, defines his intention for the service. It could be as well used for defining the actual test case to validate the specific feature, because we can look into that way. Operations, they would like to deploy a specific new feature into the network. They do agree with the developers or with the architect how the solution should look like. So they say, okay, this is the configuration we want to push down to the network, and this is the input we want to have. In that way, we can tell them, okay, so now it's a very simple way for you to define your intention of a service and your expected outcome. And let us take care about making the magic, making sure that actually the software addresses your need, right? Because if we don't get this from the operations at the very beginning, how do we validate that our intention is in line with their expectations? So let's try to get them engaged at a very early stage so that they're going to be able to contribute into that one. And that they're not going to be able to say, oh, we don't have time for it because, we don't have time because we're fixing everything that's back in the network because we're doing things in a manual way. Okay, so the user pushes the branch into GitLab. Within the GitLab, there is the pipeline. That pipeline gets executed. That pipeline identifies the GitLab runner, and that's the GitLab runner that is running locally on your machine, right? So you know that everything is going to be done is going to be executed on your machine. Obviously, we could say that depending on the branch name, is going to be executed. For example, if there is a Git flow process defined, we do have the main, the feature, the develop branch. The develop branch could be executed in a staging environment. Then the feature one could be in some kind of pre-staging environment. Then the developer branches could be developed and executed on the local machines, right? It's all about the setup. GitLab Runner launches the service as a code container, which helps to run a number of functions, validation, and then finally pushes down the configuration into the NSO, and NSO pushes down to the devices. We can run some tests and validate the final result. It's an example of the pipeline, nothing overly complex, just to highlight the key stages within the pipeline. So I start with some kind of preparation, validation of the input, some kind of linting, Python linting, YAML linting, just to make sure that the input is correct. Then we do a dry run. Then we push the configuration. Then we go ahead and we run robot test cases. Those robot test cases can be then used to make a decision. Do we want to roll back or do we want to deploy into production, right? If it's a feature branch, we're just creating, for example, merge request. And then if this one is fully automated and fully tested, this merge can be automatically approved and merged into the develop branch, and then develop branch could run the tests or deploy it into a pre-staging environment. And then we do send some notifications, or we can do anything. But just highlighting here, we're sending some notifications just to show that there are a number of features that we can do. There is a session at 1:40 about a number of different WebEx integrations, including how you can notify, create notifications to your WebEx spaces by Armor. So if you'll be interested in do some further details about WebEx integrations, feel free to join that session. I do have a demo now. I've recorded it. We'll see how it's going to go, because I did see a number of challenges with running the live demo. So maybe doing the demo is going to be a little bit more efficient, but let's see how it's going to go. Okay. Is it running? Yes. So my sample service, it has basically two different repositories: sample service and the service as a code. A sample service repository is just a package, NSO package that does a layer 2 VPN provisioning. Nothing fancy, but again, that's a concept, so you can look into it and take it and maybe make use of it, right? So you see, it's very basic, but you can replace it with much more complex services that are going to be put in there. On top of that one, there is a Docker file that helps to deploy it down into network. So basically, it creates the image that it's installing this package, installing NSO version of your selection, is putting the nets and deploying the image. Then we do have the service as a code, which is the concept in here. What's the structure in there? Well, first of all, we've got the GitLab pipeline definition file that defines the whole pipeline, how it gets configured. Then we do have a setup, which is deploying our environment, it's a local environment. We're deploying the GitLab runner, we're deploying the NSO Service as a code container to our local environments. We're registering it together with the GitLab. So what GitLab is going to be executing is going to know to execute it locally. Then we do have a config file that basically defines some of the basic settings. Here we define that the rollback in case of failure is going to be the last commit. We define what kind of service we're using. We're putting here the WebEx room notification ID, and we're making use of it. Then we do have the Docker file, which is basically deploying yet another container that is used for testing. Like, for example, that has requirements to configure some packages to run linting, Flask, and things like that. Okay, so with that one, we can go further and we can look into our service definitions. Right now, starting service definition is empty, right? You just say, okay, there is some kind of service we want to deploy, but it's empty, so we're not deploying anything. And there is a robot test case, right? A robot test case that can be later on used, and the result of the robot test case to support whether we're going to commit, merge, rollback, notify. Sky's the limit, right? What we want to do. Okay. As I was mentioning, we do have there two different containers that are being pushed into a container registry. on the GitLab, one which is a service as a code, one which is our sample service. And then let's see how it goes, right? I mean, what the developer is going to do. So right now we're going to look, and the README file here describes the different steps that are going to be taken by the developer or by the operations who are going to be using with that one to create a new service. Okay, so just to recap, that's going to be the pipeline that's going to create NSO service as a code service instance. That's a sample service. The sys service is defined in the YAML file. We do have a script that does the provisioning, that retrieves the customers or the intention within the file, that uses RESTconf to push it down to the network. So the first step for the developer or for the operations, or we can automate this kind of preparation by just showing it to you that to understand what are the different steps, we're pulling the relevant images from the GitLab repository. One from our repository, one which is the GitLab runner. With those two different repositories, then we're going to run the setup. So we're going to first out create our branch. In this case, I'm going to call it demo user. I'm creating this branch, and I'm going to set up my demo. So basically, I'm going to run those. That's a simple shell script, which is creating two different containers. Those containers are running locally, but that container is going to be registered with the GitLab. So here I can see that there is a GitLab runner container. And this container, if I'm going to check in here, and I've got the CICD settings here, I'm opening CICD settings of my repository, and I'm going to look into runners. I'm not using shared runners for this project, so I'm disabling shared runners, but I have assigned project runners. So here I can see that my GitLab runner is running locally on my machine. It's right now registered with GitLab. So whenever I'm going to push the code into that specific branch, that GitLab runner, based on the tag, is going to be used to execute it locally on my machine. I was mentioning that there is another container, just serves as a code container. There is nothing else than just a basic Python container with some of the libraries running, so I can run linting. Again, it's a simple concept, right? You can build your pipelines to the extent you want. What I wanted to highlight is, let's validate something, let's do a dry run, let's deploy, and let's test it. For testing, we can use robot test cases. Obviously, you could say, but we could actually just, that's very similar to just running a test cases itself, right? To a certain extent, yes, but it's not only about running test cases, as well about integrating with the operation so they can use and make a benefit of it. And then the final stage is notifications. Well, you can put a number of different integrations, a number of different steps. Here I'm just showing one example of integration that we can do. This integration could be integration with the WebEx, so we can notify our community about the status and progress of it. So in case of WebEx, I'm just creating a bot, NSO Service as a code bot. I do have a token. I'm using this token that I'm going then to configure my variables within my project. I'm configuring my variable in here. That's going to be the WebEx bot token variable. And that variable is going to be then used to indicate that this bot is going to be pushing down the notifications into my WebEx space. Okay. I need as well to say what kind of WebEx room I want to do. So I'm just going to another API for the WebEx rooms. So there is the API that can retrieve all your different WebEx rooms that you're a member of, just a basic RESTconf REST call. So you're running it, and I'm going to be able to get all the different room IDs. So I can then select the relevant room ID that I would like to do. In this case, I have here NSO Service as a code developer day session that I've just created locally on my machine. In my WebEx space, obviously, I'm going to add all the developers and operations that are part of that room of that project into that room. I'm going to update it in the config definition YAML file, where I'm going to say that that's going to be executed. Yes, so you did see an error. The error is there because the specific branch doesn't exist yet, because I actually didn't push the branch yet, right? So I'm going to do right now, let's push that branch. Let's see how it's going to be done. Let's see that it's going to be executed. I think it's running. Yes, it's running. So to push that branch, let's open the Visual Studio Code and let's publish the branch. So I'm just going to publish the branch. The branch is going to be published into GitLab repo, and I'm going to be able to see that the pipeline is going to be executed. Yeah, that's the WebEx room. And now I can see that it actually opens up because it's already on the demo user branch, so the branch was published. So I can see that the pipeline is running, right? The pipeline is running. The first step, which is some kind of linting, has been completed. The next steps are right now ongoing. The next step is try to do the validation and try to do a dry run. The next step is going to be then to push it down to production. But my branch is empty, right? I mean, my service definition is empty. So I'm actually not pushing any configuration down into devices. So what would be the next step for a developer for the operations? The next steps for the operations would be to go into the service definition lamp file and to create our service intent, right? So here what I'm saying is, okay, I'm going to create two different services, each service between two different devices. It's going to attach those interfaces, device, VLAN IDs. The layer 2 VPN is going to have some specific parameters. And in this case, I'm just going to open, for example, web IDI, so that I'm going to be able to create my service intention, right? So operations, they could say, okay, I'm creating my intention. This is the intention of my service. I'm as well defining how the configuration should look like on the devices and run it. Okay, the idea is that's going to fail, right? Because the service doesn't support it. But if we go through a test-driven development, we do have intention, we do have the expected configuration, then we can tell it to the developers, and developers are going to see in their WebEx room, say, oh, yeah, that doesn't work, so I need to go and work on it, right? So it automatically allows us to create a merge request. So let's create a merge request. This merge request is going to be, we can take an option and merge when the pipeline succeeds. Okay, this pipeline is right now running, so we can see the different steps of the pipeline that are going to be happening, right? So I can click that the pipeline already merges when it succeeds. If it fails, obviously it's going to have sent some further notifications. So now it takes some time to run the pipeline. So I mean, this pipeline, because it's very small, it's probably around just a minute, 1 minute. So here you can see we did run the dry run. The dry run gives us the actual output that should configure on a device. So it's the interface configuration, cross connect, pseudo wire, nothing fancy, service instance as well, and that gets pushed down to the network elements that are the net simulated elements. Then we do a deploy. We can see the deployment has been passed as well. So actually the device did accept this configuration, and then we go ahead with testing, right? So here we can see that the test has been executed. As I mentioned, there was a robot test case that has been executed a bit earlier. The robot test case summary is at the beginning here of the result. We can see we did run some of the tests. Those tests are as well nothing fancy, just the basic test to highlight the principle and the value of robot. There was sessions either the first or second day where we've been looking into what is robot and how Cisco has extended robot to provide a number of additional libraries to support integration. And yeah, I mean, this one gives us a link to the actual log result. So if we open it, we can see the results of our test execution. So a robot with the support of a Cisco CXTA and a number of different libraries that are extended to integrate with the RESTCONF, with NSO and the different technologies. They are providing capability to run the tests, right? I mean, in this case, it's just a basic test where we're validating that our intention is in line with what is configured in the network. Nothing really fancy, just validating that what is defined in the device is in line with what was the user intention, right? We verified that the layer 2 VPNs actually exists in NSO and that it actually exists on the devices. So that one has been configured, has been pushed down into the network. We could automatically merge it, right? And notify then merge into main, merge to develop. Obviously, let's make some mistake. I know, let's edit something. Let's type here a wrong input. Yeah, because that's going to highlight us. I mean, it's a human readable. It's very simple to define. It's as well very simple for operator to interact with. But if the operator is going to be making a mistakes while defining the intent, it's as well going to easily identify those kind of issues within the pipeline. So here we can see that that has been incorrectly configured, and obviously the pipeline is going to fail fast. Because we want to make sure that that's going to fail fast. Well, linting is okay because we didn't impact the structure of the YAML file. So the structure of the YAML file was okay. But then while translating and generating the payload into the REST-conf, or actually this is where we send it down to NSO, NSO validating the input, clearly indicated that the IP address is not a valid value. I mean, and here the data model validation of NSO based on the YANG has already raise the flag that it's something wrong. So we managed to fail fast, right? Okay, then we send another notification. This case is a notification of failure, and obviously we can see it in our NSO Service as a code room that there was a failed execution within the environment demo user, and then that there is this pipeline that we have been using, and that this pipeline has failed, right? Okay, let's just make sure that we clean up the things. So I'm just going to edit it, make sure that it's a proper configuration, push it down, commit, look into my merge request. In my merge request, I'm going to just check if I do have this automatical merge once a pipeline has succeeded. Yes, indeed, I'm clicking in here, merge when pipeline succeeds. So we're going to be waiting right now for the pipeline execution. Once the pipeline is going to be successfully executed, it can be merged and promoted into a relevant environment, into a relevant ecosystem. Again, it will depend about how do you want to set these things up. It will depend on what is the relationship and collaboration that you did agree within your organization. It could be used to push down things into production, right? Though it will work in some organizations, it will not work in other organizations, right? I think the mature organizations that are using net DevOps, they're using GitOps, they can benefit from that one. For a big service providers or for, let's say, huge companies that have been there for ages and are transitioning towards automation, for them, the network is the source of the truth. But that might be as well useful for them to try to engage operations at the early stage so that operations define their intention into the repository and then help to work closer with the developers to improving the quick and the speed of pushing this down. Right? Here we can see pipeline has been fully succeeded. We can see that the merge has been done, that the source branch has been deleted. We can see that there is just a single branch that is in there. And that's the end of my demonstration. Conclusion. Your mileage might vary, as I mentioned. It will depend. That's not a solution that will work for every organization, but the concept is there on a GitLab. If you want, check it out. If you do have any questions, I'm here to answer them. I mean, right now we're going to break for lunch, so we don't need to hurry. The lunch is in there, right? So sorry for those that are watching us online. I mean, you're probably going to have some of your food, but yeah, I'm not sure. Do we have any questions on the Slido?
No, Slido, no questions here.
Any questions from the room?
Can you just show so they can take a picture of the?
It depends how you set up the things, right? As I mentioned in this example, it depends on the specific user environment, right? So the way I did show it as a part of the concept is that NSO instance is going to be spinned up per branch, right? So you create your branch, you're going to spin up NSO within your branch system, right? But that's the NSO that is already going to be spinned up with a relevant service, right? Because this is when you spin it up for a relevant branch for NSO Service as a code, right? Where you're going to work on validating the input, right? Now, if the developer modifies NSO Service, it's a matter about building it and updating the existing container, right? You probably want to have potential automation where modifications to the code are going to automatically trigger changes and reload your packages, right? I think that was mentioned by the Croatian telecom guys on the first day, right? That they had this, I might be confusing things in here, but they're stating that they initially had the integration that anytime that the developer saves the code, it automatically builds it, but that is probably problematic. You might not want to build and to redeploy packages every time you save the code, because you're working on a number of different packages, a number of different files. You probably want to manually say, okay, I want to do it maybe on a commit, maybe on a push, maybe on a different manually triggered action. So it's again your decision, right? Okay, so the question is, what do we think about the push-based approach and the pull-based approach in a GitHubs? I'll give you the answer that I don't like to get, which is it depends, right? It will depend about maturity, about your organization, about people that are engaged and are working together with it, right? I mean, ideally, you would like to have dev operations team as well engaged into that one and do the proper updates from a perspective of working with the Git. But what you can expect from operations is that probably you help them define the API. Maybe the best way is for them to tell them, guys, this is the file that you need to modify. Go ahead, modify it on a web UI within the GitLab or within an open IDE, right, within the GitLab. So that means basically they're going to be modifying it already on the branch, which is going to be residing within the GitLab, not local local copy of the branch. So there is not a good answer. It depends about the maturity about the organization. If the operations are up to speed and they're happy with that one and they're working locally on those changes and they're pushing it, it's going to have a different solution rather than if they're just going to be making some changes online. I think there was a question.
Yeah, so should we be thinking about the service definition YAML as kind of bigger than the NSO config? Because it could be other systems, it could be other types of things that you want to encode, because otherwise wouldn't you just use like JSON to just play it straight into NSO? It felt to me like you would, as the intent, you could actually put more metadata in addition to just config.
So yeah, thank you for this question. If I get it right, I mean, you're saying what level of abstractions are we going to put into this kind of service definition file, right? And yes, I didn't put here the device config. It was like a service config, but still, it was kind of low level, right? It was the RFS service. If you would like then to build your service into a little bit higher level of abstraction, you're going to build maybe CFS facing service, which is going to be much more exposed into the operations, then definitely that service is going to have a high level of abstraction. It's going to define it more from the service concept. That is being used by the operations to, for example, provision it either through SS system or through kind of web UI. So definitely that would be a next step to make it much higher level than just the RFS service level, because that one indeed you could do it in a different way.
Okay, I think we have to end the questions, but Maciej will be around, so you can ask him any questions that you have. The launch has started, I mean, 3 minutes ago. So be back in 1 hour. We will have a very interesting session about streaming telemetry, so be here. And you can go now for lunch.
Thank you very much.
Everybody.